Hey everyone, welcome to Office Hours. We're going to get working on some Chapter 5 right away. I think everyone can hear me. I got to move up the audio channels on this. Yeah, there it is. Music might be a little loud. That should be good. Awesome. Good to see you, Jack. I think right. Mackenzie and Riley. Let's throw some points. And we're going to start Chapter 5 homework. So if you haven't, I sent lots of announcements. If you haven't done it already, get Chapter 5 homework going, Part 2, Chapter 5 homework, Part 2. We're going to work on that. I need to put something in place for tomorrow. Okay, let me do this so I don't forget, and I have it going tomorrow, and then I'll forget. I'll be like, what is going on? Get ready for a cool transition. Do you have Chapter 5 homework, Part 2 open? Who's got it open? I'm going to need your help to do this. Your help to do this assignment. We're going to need Mubot's help. We got the apps going on right here. What about Part 2 quiz? Yeah! Oh, we will get to that, Keely right there. We will get to that. Check out this new intro. Let's do it. Here we go. It's not really an intro. It's a little transition. Chapter 5 Part 2 quiz. What they said? Yeah. Well, should we do the homework pretty quickly here? Let's mark the homework in here, and we can just try to burn through it really quick. You'll notice there's a lot of similar questions, but we'll try to do the full homework so it's in this video. So everyone should be able to get hundreds on the homework. Let's mark this here. 543, Stat 201, Chapter 5 homework. Chapter 5, Part 2 homework. Okay, so if you've been doing this, homework quick, then quiz. Jackson knows right there. Jackson getting some big points. Huge points for the class. Big points right there. Okay, why is this on the other screen? I don't know. What's going on? What's going on? Why are we here? Ooh, that's pretty. Pretty table. You can't see anything right now. I can. Okay, what? Come on, computer. Hey, kid. I'm a computer. Okay. Now you can see again, and I can't see. And I can see again. Okay. Let's get the homework going. Got everything set up to go. Mubot's in the background right here. Mubot, you can know you're over here on the screen. Okay. With that, let's start the first question. First question, here we go. Now, you want to use the apps for these, but I do suggest trying to solve them on your own. You'd be shocked at what you can do. I'm going to do these in my head. I'm going to explain briefly what I'm doing, but I want you to go to the app right now. Who's got the app open? Mubot is going to pin it for us. If you type apps in the chat, Mubot will bring you to the apps. So while I'm doing this right here, I want you to go to the apps. I want you to find the right answers. Then I'm going to show you how to get the right answers. I'm guessing this. I'm going to talk you through what I'm doing. But you should be going to that link in the chat right there if you're watching this, because you'll get the exact answers. Then I'm going to talk you through what I did. Okay, we got a mean of this and a standard deviation of this. That is 123 above, which is about 1.66 standard deviations. So over 1.66 standard deviations is between 5 to 10% because of the way z-scores work. Somewhere between, it's even smaller. It's a little bit less than 4%, 5%. So it's going to be about 1.48. Did we get it right? We didn't. It might be a little less. Did we get it right? I didn't get it right. 5.3, final guess. Final guess. Now let's go and show how to do it. I need your help to solve these, though. Buenos tardes. Well, I need your help. I need your help. What do we do on the applet over here? So how do we solve these? This is big for this chapter, and then I'll kind of explain the background again, how I did it. What should I enter into the applet? What's the first things you enter into the applet right here, which is pinned by Mubot? Help me out, because a lot of these questions are going to be very similar. What do we enter in? What do I do? You get to the applet, mean standard deviation. Riley's got right there. Let's make Riley a mod. Don't usually do it during office hours, but why not? So we go right here. We go mean standard deviation. And if you remember, I said the z-score. If we plot the point on here, and we need to find the percent using x, and we plot the point of 1275, you'll notice, looks like I was off on the z-score. The z-score is going to be down here, and it's thus, I thought it was further over. I was off on the z-score because it's between 1 and 2 standard deviations, which means this is between 16 to 2.5. You remember from the empirical rule, above 1 standard deviation is 16%, and above 2 standard deviations is 2.5 because of the 95, 5% outside, 2.5 neither tail. So this answer had to logically be between 2.5, more than that, and less than 16. Who understands the logic of how you would know it has to be more than 2.5, because that's 2.5, and it has to be less than 16, because from 1 standard standard deviation over 16. So logically, we can see the answer of 7%, which is rounded to one more decimal now, is 7.2. I was very off in my guess, but 7.2 is my guess, or not guess now, that is the right answer. I wasn't that off. I said about 5%. It's 7%. Now we want the steers under 1250. We'll just look at it visually. 1250 is about right there. So I just want someone to put a guess in the chat. Don't make it a right answer, but 1250 is going to be right about here below. So how much of the curve is that? If you were to shade in there below, how much of the curve is that? How much of the curve is there and below 1250? I've got a guess. How much do you think it is? Ooh, we'll be doing that, Adeline, here real soon. 90% is a very good guess. I think we'll just try 90% flat. Very good guess. I think it's going to be closer to like 89.2. No, we didn't get it, but let's go right here and go below 1250. So it's 87.8. You notice, great job, Jackson, and great job, Jackson, too. Jackson duo for 1,000 points. And notice we get the exact answer, and our guesses are pretty close. If you can draw it out and visualize it, you're doing pretty good. So next, we're going to do the full homework. Then we're going to do all the quiz questions. So hang around, Adeline and everyone. Notice this says between 10:25 to 11. I'm going to delete this, or I'm going to make it so it says 0. And we're going to do what it would look like visually by going here to 10:25 about and 11:25. So it would be something like this. And that looks like 14% or so. I mean, it's hard to tell. We'll just take two guesses. 14%? No. 13%? No. That would have been cool if I got it. And then we go between, and we just go between the numbers. And the actual answer is, really? Oh, because, yeah, this is the bigger portion. That's the one we've been the most off on. It's all right. As long as it looks visually correct, it is. I should have guessed way bigger because this is 34% between here. So that's 34%, and we're basically shading it over to their side. You're not meant to guess these. You're meant to understand how it would draw out. So I was pretty off on that guess. The other guesses were good guesses. Let's look at the next one right here, and this might be very similar to the questions you're doing. So Adeline and everyone, really good questions. But let's think about this. What could we do to 30 to make it understandable via this curve? I want you to tell me what you could do to 30 to make it like how far it is away. What could you do to 30? Let's draw the curve, and I want you to think about what 30 you would think about with it. You should always be thinking, if you get the mean standard deviation, what is the what of 30? I want one letter in the chat. You should be thinking, can I turn 30 into a what? Which you can see it down here. We can guesstimate it. So could I turn 30, which is right about there in that window, could I turn it into a what? A z-score. Keely knows right there. Points for Keely and everyone. Turn it into a z-score. And the z-score is obviously between 1 and 2 standard deviations. And when you look at it, it's about 1.7 or 1.8. So we should be able to take some decent guesses at this again. I think, I'm trying to solve it. I'm taking a look at it. It's going to be about, okay, it's going to be a little bit less than 5%. I think I got it this time. 4.4. Check the answer. We got it. I didn't even use the applet. This goes back to the previous one where I knew it had to be more than 2.5, but I knew it had to be less than 16. And if you look at where it's at, it's logically closer to the 2.5 because from here is the extra we're adding on. That's the extra. It's hard to make it do it because it goes to the other view. But the extra is that bit there and then the 2.5. You don't need to guess it, though, because you just go above and you enter in the 30, and it tells you the answer exactly. Now, below 13 is down here. Just visually tell me what is the z-score for this. Don't even find it. Visually tell me 13 looks to have a z-score of about what? Just visually. Visually, 13 looks to have a z-score of about what? Visually, this is where 13 would be at, where that line is at. Close, negative 1.5. And great job, Jackson and Jake right there, negative 1.5. And then we can confirm that answer. This is practicing a lot of the work right here by saying observation of 13 minus mean of 20.9 divided by standard deviation of 5.3. And I got through 1,000 points for that. You were virtually perfect. And now I've got a guess of what the percent would be. It has to be somewhere between 5 to 10% and probably closer to 5%. Because I know some extra numbers. We're not right. We get one more guess here. We got it. We guessed the answers. And that means if we can guess this last one, that means we can get the full thing right without actually technically using the applet. And if I am correct right here, the last one will be 88.8. And we did it. Let's show how these answers are found if you are using the applet right here. If you are using the applet, you can just go below and go below 13. And there we were perfect on it. So, wow, good points right there. Now, here's the thing. The last one is the area between. So remember on that first one, we did the area over 30? So what do you think I did? If the area over 30 is the white area here, and we're trying to get the gray area between, I would take those two numbers and subtract from what? I might draw it out more visually for you. This is the way this problem works, that you don't have to use the answer for the last one. Because when you solve this problem, this is answer 2. Oh, geez. Oh, geez. That's answer 2. This is answer 1. And this is answer 3 in the middle. So tell me why you don't have to use the applet to get answer 3. Who can explain mathematically what's going on here where you don't have to use the applet to get answer 3, which would make it a great test question? Do you see it? Well, it's because the whole curve's been shaded, which is 100%. So you can just say 100% minus answer 1 and answer 2. Minus answer 1, answer 2. Exactly, Jake, right there. Perfect answer. And then you can use the applet still. You can go between, and then you'll get the area between, and you can see it visually. So there's answer 1, and there's answer 2, and we're subtracting out of it. Not quite the empirical rule, because they don't land directly on exact numbers. And Mackenzie, let's throw you some points. I'm throwing you 1,000 points, Mackenzie, for that answer. We love all answers here, because the empirical rule only works when you land on 1, 2, and 3. These numbers have decimals, so the empirical rule it doesn't perfectly work out. And I know you're not meant to solve them like I'm meant to solve them, but I want you to take some decent guesses, and I want you to try to draw it out. So get your drawings out, try to do it, see what you can make of this. So this one is about, we might not need the applet for it. Is this distribution normal? Ooh, what is this called? What is this called? I just want you to acknowledge it in the chat for some points. What is this thing called? And then I'll explain the answer. Pretty easy question, and we'll be getting to the quiz here shortly, because we only have a few more to go. It is bent. It is, and I'll throw you points for that. It's called a normal probability plot right there, and that's a plot that tells you the probability it's normal. And when it's normal, it follows the line. So since it does not follow the line, it does not follow the normal. So we go right here, and we can actually see some data really quickly. I'm just going to show you one of them. We'll go to the Pokemon data, and to make a normal probability plot, really. To make a normal probability plot, you simply go here to Analyze Distribution, because it's a quantitative variable. You find a Y variable of interest that you want to analyze. This has some skew to it, so we're going to see that it has problems towards the high side. And then we add a normal quantile plot right there. And it's not horrible, but notice here is where it starts to break the pattern of normality. And that's literally these points right here. Like if I start highlighting these points, you can see those are the points right there that break the pattern of normality because they have too high of a skew. And we could probably pull the axis out a little bit more, and you could see more what's going on right there. But it does have some problems, not the worst. This one, on the other hand, is horrid. That's horrid. Extreme right skew is being pushed to the right side. So no, because it does not roughly follow the diagonal line, which is the perfect normal. If it isn't normal, how does it differ? It is right skew. We will not test you on that. But right skew is pushed to the right side. Left skew is pushed to the left side. What do I mean pushed? It's like if you went in and pushed this to the right side, that's the way it's skewed. It's just how to view it visually. Also, you can see that there's points that are too high above the normal. High points indicate, like this is the normal, is the blue line of what we expect. And there's points that are higher than we expect given the normal. And high values is right skew, right is high skew. Little trick on that last one. And yeah, it's multiple choice. You can get it right. Okay, so here is the data to start. It's got a problem of what? Why is this not perfectly normal? It's got some what modality going on down below. I gave you the end of the word. It's got some what modality. We're almost done. This one's a short one too. That's not normal. That's not normal. Some bimodality, we want unimodal, symmetric are the two qualities of the normal. It breaks the bimodality right here. So if we take a look at the normal probability plots with the full data set, you're going to see there's a problem, especially here on the low side, where it doesn't follow a line so perfectly because we want it to have this linear pattern, which is what happens after we remove this one school district from the data set. So the data is bimodal. I don't think it's right skewed. And then which of these, 1 or 4 is right? About blank percent would fall within one standard deviation. Is it 1 or 4? When you talk about the empirical rule, if the empirical rule is correct, then we should see what? Which the empirical rule states the percent of data within it is A. Yep, 68, 95, 99.7. If this said 2, it would also be a right answer, but it doesn't say 2. And then if there was a 3 with 99.7, it would be the empirical rule. So with it removed, it does become normal, is more approximately normal, and that's the key right there. Remove the outliers, get normality, and you're not removing them because you don't like them. It's you can remove them if like they don't. If it's like a different data set, you're like, let's analyze students, and you've got like high school students and college students. You could then split the data sets, or the Kentucky Derby data set, where we remove out the years where the track had a different length. It's not because we don't like outliers. It's because they have a different system or different analysis that we want to do on them. So we're separating them. Last one or two more to go. What can we do to analyze? Which of the following can be used to make a normal probability, or which of these can be used? Oh yeah, good. There's a very good trick one right here, because which of these is a horrible wrong answer? Actually, there's 2 horrible wrong answers. Can you tell me a horrible wrong answer on this to analyze normality? A horrible wrong answer. B, gosh, Keely, you're doing so great. I thought I could trick people and ask hard questions. You're totally right. Bar charts are for categorical data. Yes. So you can't use bar charts because that's not normality. You also can't use frequency tables because that's not normality. Technically, someone could use a box plot, but they're not really good at showing shape. They often hide features that we would probably, if it had histogram, it'd be tough. So normal probability plot, which we just saw in the previous questions, which are a plot to tell us if a distribution is approximately normal. Last one to go right here. This one is dealing with when we shouldn't use the normal distribution because the data is extremely skewed. And you can see that because we have a very high standard deviation where the values would go negative. So I'll do this one pretty quickly right here so we can get to the quizzes. So drop more quiz questions. I'll make sure I didn't mark them yet. Drop those quiz questions. We're going to be doing quiz in about 3 minutes probably. Okay. The top 10%, you need to go to the applet. I can figure this out probably though because there's a trick. The z-score for the top 10% is always going to be 1.2816. If I times that by the standard deviation of 85,000, and then add that to the mean, I can actually get to the top 10%, and that should be the answer. Round to the nearest dollar. It did it perfectly, and that's got it. That's because every time you use the applet, if you were to ask for the z-score of the top 10%, the z-score of the top 10% will always be at 1.2818. And that's when you have the normal curve right here, and you're looking at the z-score of the top 10%, which would be right there. You can also graph the top 10% by doing the following, and as I said, it's 1.281716. I swear. No, it's 16. Got to memorize it better, Brian. 1.2816 is the z-score for the top 10%, and then I simply went that many standard deviations above the mean. Now, you don't have to solve it that way. Excuse me. You don't have to solve it that way. What you can do is you can just enter in the mean of 85,000. That's not the mean. The mean of 89930 and the standard deviation of 85,000 and get the exact answer right here. And it'll even carry some more decimals. You can then round to 0 decimals. And the question does have some leeway in it. So this is another acceptable answer with more decimals carried out via the applet. Let us know if there's a problem, but make sure to just carry your decimals. But the z-score of 1.28 is what can be used. And so when you think about this, if you look at the distribution, it's pretty darn obvious because this is income. And what do you notice about this distribution? A lot of the numbers are what? Last question, then we're doing quizzes. A lot of these values of income are what? Which indicates, I don't know if this would work because it is income. You have to look on that far side over there. A lot of these values of income are what? Look down there. That's income. That's not like how much you spend in a year or how much your net is, or that's income. I don't know if that's income. What do you think about income? Clearly, income should not be what? Clearly, income should not be what? What are these numbers? This number is different than that. Negative. Great job. Income should not be negative. Yeah, Skelter's happy right there. Income should not be negative, and you can see other evidence of skewness, and this is just us modeling it with the normal. So evidence of skewness would be that the mean is where to the median. I said that would be the last one. So the mean of 89,000 is way above the median, indicating a right skew. The mean follows the skew. Also, the standard deviation and the mean are very close, indicating there's it's probably skewed to the right. It's probably high outliers. It's only possible to use this if it's unimodal symmetric without outliers, which means normal. And then we have evidence of non-normality because since the mean and standard deviation are very close, it's probably right skew. Here it is. Since the median is much less than the mean, or the mean is much higher, and the standard deviation and the mean are very close, indicates a right skew. Yeah. That's got it. Okay. It's quiz time. We might even be able to do the full quiz. Might just be able to go all questions, get them all done. I think we could. Who'd be in favor of us just literally doing every quiz question? Let's take a vote. Would people be okay with that? Let's do we could just do. I'm serious. We could do them all. That way, someone's like, I'm stuck. I'll be like, we did the full homework. We did every quiz question. There's none. So you're about to see them all. All right, we'll just do them in order. It's the easiest way to do them. Let's do it. Okay. Okay, man. You happy, Skeletor? Are you having a good day? Yeah, you are, man. I need to bulk up like Skeletor right there. He's probably skips leg day, though. Okay. First question. Mark it in the notes. Let's do it. 25. No one knows if Skeletor skips leg day. Chapter 5. Part 2 quiz. I have a question about data analytics pivot chart. Can I email it to you? Yeah, we can probably do that here, Grace. Thank you, Grace. Let me throw you some points, Grace, for being here and asking that question. You can email it. You can put it in the Discord too. And let me know this question. Use the normal model. Okay. Where do you think we're going to go right away? Where do you think we are going to go right away? Where would you go to start solving these problems? Where would you go to start solving these problems? The applet right there, the apps. Man, I was trying to do it quicker than people could say it because I'm like, must figure out answers. Must be quick. Must go. Go. So we're going to go to the applet after Brian takes his quick guesses. This one's nearly impossible. 46.2. And then this one, the last one. Oh, man. Okay, that one's going to be 33.2. Okay, did I get any right? 0. We got all the apps in the chat. We're going to the applet right here. And the first thing we enter into the applet, we're going to put it dual screen up here so we can see it at the same time. The first thing we enter into the applet is the mean and the standard deviation. Let me disappear. So the mean of 100 and the standard deviation of 16, I do suggest trying to draw these out. We'll see how close I was in my guesses. Now we need to find the p-value, which is the percent. We're finding the percent using the value x. The first one is over 80. And so we simply say over 80, and there it is right there. That does not look, oh. Okay, what's the issue? 1,000 points, what's the issue? Someone said, Brian, the applet said 1. So what's the issue? What is the issue? What is the issue? Do you see it? There's an issue. The applet's working. It shows a good picture. Round 2, 1,000 points in the chat. Nice job. Yep. I was doing a previous question. It's 80. Come on. Nonsense. We were that off. We were a 10th off. A guess. And we were a 10th off. That's nonsense. Okay, the below right here. It says below 95. Okay, not nearly as close. So yeah. And then last but not least, between. Very hard one to guess. There we go. 26.8. Not horrible guesses, but the first one was very good. And there's those. That should do it, and that should get it correct. Do try drawing it out. A lot of times when you see these, I'm doing them in my head, trying to think of what it could be. I was trying to work very quickly. If I had more time to draw them, I could probably do better guesses. You should be able to draw anything the applet's doing. The applet is just doing it for you. So do sit down and try to draw these out. You get a lot of practice by just drawing the normal curve. Maybe we'll do that for one of these coming up. Just say, hey, Brian, draw it out. We'll do it. Okay, that is one down. Only like 7 more to go. This is the classic NFL one right here. So this one deals with data that might not be what. As I take the note, tell me about how that data looks. This is the NFL one. Tell me about how that data looks. Tell me about that data. It looks very skewed to the right. So should we be using the empirical rule and methods learned in this chapter on this data? Yes or no? Is the normal model something we can use for all data? Like you use, no! You only do it when data is normal. Sometimes you do a normal probability plot to check to see if the data is normal. Okay, so let's see what they got. Okay. First thing we're going to do right here is to figure out what % of receivers are expected to get more than one standard deviation above. I wish they said use the empirical rule. So because of this, I have seen some students get it wrong using the applet. What you want to do right here is think with the empirical rule. They really should have said that. I love this question. Otherwise, here's a nice question. What % are expected to get more than one standard deviation above? Tell me as I start to mark this right here, if you were to go above one standard deviation, what % would be expected to get more than one standard deviation? They really should have said use the empirical rule, because if you use the applet, you'll get a decimal answer and let us know if you did. So the answer is this, and it's 16. Keely knows right there. Keely's on fire. So it is 16% because outside would be 32 total, and we only want outside of 1 and -1. I think everyone knows, been practicing that empirical rule. So that is above one standard deviation. It might say 2, and that'd be 2.5, but we're talking about 1 in this instance. What does this mean? About blank % of receivers, or blank receivers. So we have 508. So if we'd expect 16%, what would we do right here? We'd take 508 and do what to it? We'd take 508 and do what to it? So we expect 16% of the 508 receivers. I'll do the next part. Just do what to this? I mean, if we expect 16% of the 508 receivers, that's what we're saying. I expect 16% of the 508 receivers. So what do I do? It's like I expect to make 16% of this money times by, there you go. There you go. There it is, and round to the nearest number. Then we simply go up one standard deviation. We don't delete that last number. We go up one. Nice job. Mackenzie knows too. And then we go up one standard deviation. The mean is at 253.763. We add to it one standard deviation of 312. Remember, we're just going up one standard deviation. That's all we're doing. Copy pasting in, rounding to the nearest whole number. What's the problem right here? The data is extremely right skewed. We are good to go. Another question done. Please slow me down if I go too quickly. The question is just seeing if you understand what it means to be one standard deviation above the mean. So here is the mean and one standard deviation. It doesn't hurt to go to the applet and also enter in the numbers. And you could see if you enter them in, I'm just going to do fake data here for a second, but if you enter the mean and then you enter in the standard deviation, whatever it is, you could then look down here at the bottom and see one standard deviation above the mean. This is not the answer, but you could look and see one standard deviation above the mean. Do make sure it is doing one standard deviation, which that does appear to be true. And it's just drawing it out for you, which we could also do. And we could do our sketches here and do the mean plus one standard deviation. That's mainly the learning objectives of that one. So we're on to the next one. We're just going really fast and really quick right here. Please slow me down if I go too quickly. We'll probably have time for some data analytics because we've got until like 3:50 or so. The Glassdoor. Do people like this speed? Like, I feel like I'm going fast. So you're here though, so you get to say like, no, Brian, you're going way too fast. I need speaking too quickly. I'll take your advice. We got the Glassdoor company right here doing some data analytics on their distribution of what's going on. It's people's compensation rates. And they want to know what % of CEOs are expected to get more than 2 standard deviations, and they're using the empirical rule. I want to point to a number, and I want you to tell me what number it's associated with on the empirical rule. What number is associated with 0.15? Yeah. Thank you, Keely, right there. Thank you, Keely. That's a lot of positivity. What? It is the 99.73 standard deviations, exactly. 34, that one's tricky. Do you know which one 34 is associated with? This is really good, like, memories. Like if you're like, 34 is associated with what? 17 is not an answer. My gosh. Keely knows it all. I'm very, very impressed and very proud. I thought that would get people. You are right. That's between 0 and 1. great knowledge. Throwing out all the points here. So you could do all of these and we could practice all of them, but you should know things when you see a number like 34. It's tricky because a lot of people think 32% is the total area outside of the 68. But if you cut the 68 in half, you get 34, 34. A lot of people mix up these numbers when they do the empirical rule, and that's 16 here and 16 here. And then you have to get 100% because notice how 34 to 16, 34 to 16 down the middle of here. So practice makes perfect. Know the numbers. And the answer we are looking for is 2.5 because 2.5 is if you go here to the second standard deviation and go above it, you would have 95 in the middle, 5% total outside, and that would leave 2.5 on either side. So you're here at 2, here at -2, and then you put 95 in the middle. It's the worst 95 I've ever drawn. And then you go here and do 2.5 and 2.5. Little sketches like this help you remember and keep you answering them quickly. Is this appropriate for this data? Well, the data's got to look normal, and the answer is, ooh. Is it appropriate? Do you think we should be using normal techniques here? Yes or no? Just yes or no in the chat. Yeah, that looks about as normal as I've seen. And data usually doesn't look this perfect. So, hey, that looks pretty darn good. Yeah, I agree. It's pretty unimodal symmetric, yeah. And then they go down here and they basically do it again. And then it looks even more normal. So, sure, this looks normal too. I don't know why they did the same thing. They should have made it skewed to begin with. Maybe that's the trick. Or like, maybe that's not normal. Trying to trick you. Okay, I'm serious. We're just gonna fly through. We're about a third done right now, maybe a quarter. Okay, next question. 35, 43. This one is, we got someone working. Oh, just talk to me as I take the note right here. Talk to me about this. Your friend's like, hey, I heard about that normal curve. Here's my data. You say, what do you say to them? Yeah, about that. You got more of a uniform, weird looking distribution here. You got a small sample size also. You notice there's 3, 2, 1, 1. Sample size like how many? 25 trees, 27 trees. No, it's not really unimodal. Man. Oh, good. Okay, it might be symmetric. Okay, it's not really unimodal. This is tricky. This is way harder. It looks multimodal. It does, doesn't it? Let's go not unimodal symmetric. But it might be symmetric. No, it's such a small data set. This is garbage. You don't have enough evidence yet. It's B. I'm going with Keeley right there. Boom. 1,000 points. We don't gotta debate this. The whole point is it's not normal. That's the whole question. Don't you dare use the normal model on this data. It's not normal. Don't do it. Only use normal model on normal data. Okay, I'll get this next one going right here. Talk to me about it. I'm taking the note. You talk to me about this. We have on the right a normal probability plot. Don't read their answers. Exactly, Jackson. Don't read their answers. Think of your own. The better you know your answers without having to read their answers, the more you actually know it. So don't read their answers. Think about how you would talk about this and what it would mean. This is a normal probability plot. This is a histogram. That's an outlier. That's the outlier there in the same graphic. But overall, what are your thoughts? Overall, what are your thoughts? Don't read their answers. We'll have an answer in a moment. Yep, pretty unimodal. A tiny bit of right skew, right? A little bit. This monster man is barely existing. He's like, I'm not quite a monster man yet. He doesn't even have a tooth. He's not a monster man. Yeah. And then, and the positive nature, does it say positive? Good answer, Jackson. The positive really doesn't matter.
It doesn't matter.
What monster, baby monster man, I like that. Mackenzie earning us 1,000 points. Yeah, he's not really a monster man. We're wondering, are you really a monster man? Because you might be. We had one time, we had blobfish or whatever. He might be a blobfish. That's the normal curve right there. So it's hard to tell because he's not really. I don't know what's going on. I think it's pretty normal, Kaya. Good to see you there. This follows the line pretty well. There is one point that's a little bit weird, but overall, the majority of the data looks to follow the normal. The curve is mostly unimodal symmetric. So let's see here. This diagram is unimodal and symmetric, and the normal probability plot is straight. It'll always go up. We don't really call it a positive relationship. It follows the normal. Let me throw Jackson some big points right there. Thank you for saying these things. When you do a normal probability plot, no matter what data, no matter what data you use, I don't even know what I'm doing. No matter what data you use, it'll always go up, but it sometimes will have weird bendiness to it. I'm not getting even skewed data. I'd have to have skewed data to show you something that doesn't look that normal, but it'll always go up. So it'll always go up. It's just, does it follow the line is what we're looking at, and that does. So the normal probability plot confirms we're working with normal data. Next question. Okay, we got a bunch of men doing the downhill slalom or whatever they're doing. So what do you notice we're given at the start of this question? As I take the note, as we rock and roll right here, what are we given at the start of the question? I ate lunch today. Maybe that's the secret to doing work quickly. Who would have thought eating lunch is a good idea? I got one of the like curry bowls or so. So good. I was like, this is goated. It's good stuff. 53 men. Well, we might have a max, we might have a min. So we're given times of people going downhill. There's the min, there's the max. Now, where's this distribution got a lot of values? In the 108s, the 102s, the 105s, there's only one 111, the 100 flats, 101s. Where's the distribution going to be built up? Where's a lot of observations? So let's think about our data critically. A lot of data is contained within where of this distribution? A lot of data is contained where? Where's a lot of the data contained? In the what's? Like 10 something. 103. I like that right there. The 103s. So you notice the 103s has a bunch of data. There's even a 103 up here. And then the 102 also has a lot of data. Now what that means is those are going to be the bigger peaks. Does that make sense kind of conceptually? That the 102 and 103 is going to be where the biggest peak is, and then it goes all the way up to 111, which means the data is probably going to have a right skew to it. So 111 is the highest value, or 112 or so if you round it, and then 100 is the lowest. Does that make sense conceptually what's going on right here, that there's a lot of data around 102, 103 causing higher peaks, or the modal area and right skew? There we go. So we don't actually have to use software. We can just look at it and be like, there's a lot of data around 102, 103. That's where a modal area is, a concentration of data. And with that in mind, we are now asked to do something with the empirical rule right here, and we have to use our applet again. So if you haven't done this yet, Mubot's talking away in the chat, join in Stat Nation. Do it if you haven't yet. And we are going to go to the applet, and we're going to put it on the screen here at the same time. Okay. Applet engaged on the screen. And let's disappear so we can do the applet. Now, this is going to get the exact percentage. Or excuse me. This is going to get, according to the normal model, the exact percentage, not the truth. But we go here, we first enter the mean of 103.90 and the standard deviation of 2.65. And then we simply say above the questionable time of 108.23. And there's the min you were talking about. Yeah, the gold medal. Earned that. I didn't even notice that. 1,000 points. I should read more of the question. And here it is. 5.1%. Now that's according to what would be if the data is normal. But how about we go to our data and we look at 108.23. How many people were faster than 108.23? How many people were, or slower, excuse me. How many people were slower than 108.23? How many? The answer lies in this highlighted portion. How many were slower than 108.23? Well, it's visually created right there in the blue region. So what would we do to figure out the percentage? We would divide by, and great job, everyone practicing along. Does that make sense? Like, that's the percent out of the 53. The question states there's 53. You could count them up. But the question says there are 53 people competing. There it is right there. And then we can just do 5 out of the 53. And that's a little bit off, 9.4. A little bit off, because it is skewed. And that means we have more data on the high side. Why does the disagree right here? Well, if they disagree, it'd be that the data is not, say the one word, the data is not what? And the answer is this, but you got to say the word, and then I'll answer the rest of the question. If the percentages are disagreeing, it's because we use this technique, assuming the data is this, and if the answers don't agree, it's probably because the data is not this. Normal, which is unimodal symmetric. So they didn't quite say normal, but they said, which is what I wanted to hear, but they just said unimodal symmetric. We talked about the data being built up about around the 102, 103, and if you look at our little sketch right here, our little sketch looks just like this, and we have found the right answer there. And what can be seen? It's a monster man. You know, you love him. He's back. There is your monster man with the right skew, right to the high, left to the low, whatever way the monster man's tail goes. So very clearly right skew. You don't got your eyeball, monster man. There you go. Right skew, monster man, and that does it. We have done another question. Okay, I think we're over half done now. If you look, we can see the end is in sight. Look at that. We're at the halfway mark. We're gonna do it. We're gonna get every question in this video. My gosh. Okay. Traffic engineer. Okay, what do we notice? What do we got here? They're giving us the whats. What are these called? Does anyone know the names of these? I'll tell you the name in a moment. Take a guess. Or you see components of it in the middle. I'll tell you the full name of this, but I want you as I type the thing here. And thank you, everybody. You know, I'm going to hit the 5,000 point button. I rarely ever hit this, but I want to say a huge thank you to everybody here practicing. That's my favorite thing is when we get a bunch of people just giving answers and practicing. Don't worry if you're wrong. Just try it out. And by just being here and talking, you're getting points. You have to be here and talk. But I just want to say a big thank you. Amazing office hours. It's a Monday. We had a few people come by for in-person. Always swing by some in-person if you want. They're before this on Monday. They're constantly 12:45 to about 2:30 every Monday, Tuesday, Wednesday, Thursday. Okay. People are right. You do see the 5-number summary. You also see like the percentiles or quantiles. 5-number summary is part of the percentiles. We also have some additional information right here. And I think the question from memory wants us to do the middle 95%. So when you think of the middle 95%, it goes from the what percentile to the what percentile. The middle 95%, this is a low percentile, and this is a high percentile. The middle 95% would have 5% on the outside. So it goes from the what percentile to the what percentile, the middle 95. Boom, Jackson on fire right there. The middle 95 is in between here to here because outside of it is 2.5 on either side. So it would have 2.5 on the low and on the high side because it's the middle 95. Jake and Jackson right there. Perfect answers. So let's go ahead and take a look and do this where it says the middle 95. The middle 95, we got the graphic up. We just simply take those values of 17 and 30.98. 17 on the dot, I think. And 30.98. Sure, we'll pretend it is that and we'll find out if we're wrong. We haven't got any wrong today. The cutoffs for the actual real data. Oh, okay, slow down. Slow down. I was looking at the real data. The real data is this. This is the real data. But how would we see what the empirical rule says or the normal model says? Because remember, the middle 95 is plus or minus what? How could we figure out the middle 95? It's plus or minus what? It's the empirical rule right now. Yeah, I just need one number. If you know it, you know it. The middle 95 is plus or minus what standard deviations? It's empirical rule. The middle 95 is contained within plus or minus what standard deviations, which would allow us to do a normal estimate. If the normal is true, we can use this z-score. Close. Let's throw points right there. It is 2 because it goes 68, 95, 99.7, which is for 1, 2, and 3 respectively. So good answers, good practice right there. It is 2. And what we do is we simply go here and we go to the mean of 23.86 plus a standard deviation of 3.57. And then we add it twice. It is 31, which is so very close to that real number of the real data. and then we subtract. You can just start subtracting down from this and go subtract 3.57, and you're at the mean again because you went 2 standard deviations down, and then go 2 standard deviations down again to 16.72. That one's a little more off, but we're going to say it's all right because I've done this question a lot of times, and which are pretty close to. They're pretty close to. Since the distribution is approximately normal, we should not be surprised. They should have shown you the shape of it, but these numbers are pretty close, especially that one is super close. So the numbers agree, so we would expect the distribution to be pretty darn normal. Okay. Here we are with the normal model. And I want people to have their applet open. I want to see if you can get all these questions right before me. I'm going to click the 1,000 points. If you can get every one of these questions right before I put in the timestamp and before I give my answers, start dropping answers in the chat to show if you can do it. If you're watching this at home, try doing this question too. I'm putting the timestamp and then I'm going to guess it, and then I'm going to do it with the applet. The reason I like to guess it is to show that if you understand these problems, you can take pretty decent guesses on these things. You can draw it out, and I'll do one of the drawings right here because it keeps saying we can draw it out. So here's all the information. I can get one of these right, I know, on my own. Actually, I might be able to get 2 right because I might know another number. So when we look at, so all we did on the last one was plus, minus, exactly 2 standard deviations, Jackson, right there. We went up 2 standard deviations. Went to the mean because we had to go up 2 standard deviations. So the mean plus 1, 2 standard deviations, the mean minus. So like if the mean was 28, and then you add to it like 3, and you add 3 again, and then you go 28 minus standard deviation minus standard deviation. So you're going up, and you could also use the applet to draw it if you want by entering in the numbers over here. Does that make sense, Jackson? Please slow me down if need be. But it said, where's the middle 95, basically, and you just go up 2 standard deviations, down 2 standard deviations. So, and that's all we did on the first one if the normal model is appropriate. Yeah, you should be good. Let me know if there's issues. The highest 10%. The highest 10%. The highest 10% is going to be somewhere about here. And that's going to be between 11, 5, 6. And then we add another 87 to it. So that's going to be 12, 43, and then 1330. That's the highest 10%. That's where this answer's at. So we just, if we visually guess this, then I'm trying to think. I'm cheating in my head by doing math. It's cheating by doing math. It's going to be about 1264. See if you can get these. The next one is the lowest 20%. The lowest 20% is going to be somewhere in here because it has to be higher than the lowest 16%. 1044. Oh, for the next one, Kaya? Kaya might be saying the next one. Thank you, Kaya. So this would be 10. If you'll get them right, I'm going to throw some points even for these. Kaya, 1,000 points for the guesses even. So the next one is going to be somewhere right about here. And you take off about 18 off that, or so it's going to be 70. So 70, 1086, I say. 1086. And that's answer 2. So let's do this one as answer 2. This is answer 1. The reason I'm doing this, oh, nice job, Kaya. Kaya got B. Kaya, that was my guess. Look at my guess. It's not close enough, but that's a decent guess, right? I'm using no applet. The reason I'm doing this is to show you don't have to use the applet. You can take guesses. You can draw it out. You can try to figure out where it's at. The middle 40% has to be within the middle 68. And I'm going to go about here and here because remember, this is within the middle 68 because 68 is plus or minus 1. So if we do the middle 40%, it has to be within here and here, and it'd be symmetric. So the middle 40%, I don't know it. I'm just going to go nice and easy and go plus or minus 40 on this. And so I'm going to go with the lower bound being 11, 11, 6, and then I'm going to go minus 40 and plus 40 because that's a little less than half a standard deviation. And that would make the top bound 1196. So these are my answers that are just pure guesses. Does everyone understand? All I'm doing is guessing these percentages right here, and here we'll do this as the numbers there. So these are all just guesses, and we're going to see how many we could get right by just taking guesses. 1264, I'll put it on the other screen. By just merely guessing by doing drawings, let's see how many we got right. If you can draw it out and take some guesses, you're on the right track. That's good practice. Because then you can look at the applet to confirm your answers. And the last ones are 1186. So remember, this is all guesses. So if I get anything wrong, it's just guesses. And then 1196. Okay, check answers. Do we get at least 2 right? 0. Okay, how will we do these on the exam? Good question, Jackson. We will show you applet pictures. And I think Kaya probably has the one answer right. I'll show you how an exam picture would look. So we would need to, on the exam, show you an applet picture. And here is how the picture could look for the first one. Are you ready? I'm going to show you how it could look on the exam. Get ready right here. Here is a possible picture for the first question. We could put here 1156 and 87. And we could say, let's go below. And wrong one. Want to find the value using the percent. Okay, so what's the answer? Well, I made this one super easy. Do you know what the answer is? It says the top 10%. Where's the cutoff for the top 10%? So you'd have to look at this picture. You have to be like the cutoff for the top 10%. And I'll show you how we could make it harder. So here's how it could look right here. So what's the answer? We could look at my answer and be like, well, I think I know what the answer is. Because the top 10% is still the bottom 90%. Does that make sense? Because if you have the top 10%, well, it divides the bottom 90 and the top 10. So the answer is 1267. Now we have an answer right. Oh, wait. What did I do wrong? I must have typed a number in wrong area. Oh, 1 decimal. No. Well, that'd be really hard to get then. There we go. So here's where it could get more difficult. How about this, though? What are you looking at right now? This is the what for the top 10%. Tell me what this is. For the top 10%, this is the what. I mean, it kind of says it. The test could give you this for the top 10%. We can make it more obvious it's the top 10% by doing this. The z-score. So what would you do with this number right here to solve to get this? Because this is how many standard deviations you have to go above the mean. So right, for 1,000 points, this is a tougher version now. What would you do with the z-score to get the answer? And then we're going to do the next one with solving it ourselves. What would you do with the z-score to get the answer? What would you do with the z-score to get the answer? So the test could show you this, and you're like, well, I have the z-score of the top 10%. So think about what the z-score means. It's how many standard deviations you have to go above the mean. So what would you do? This is if you can do these questions like this, you can understand how to do the hardest test questions. Because remember, z-score is how many standard deviations we are above the mean. So this is how many standard deviations we have to go above the mean. So go to the mean and go that many standard deviations above. I'm telling you how to solve it. Tell me the math in the chat, though. So remember, this is go this many standard deviations above the mean. So what would you do? I mean, just do it, right? Who's got it? Can anyone tell me in the chat? Go that many standard deviations above the mean. What is the math? Yeah. So the thing to remember is if you draw your curve, you'll kind of see it. Watch this. You ready? It's 11. I'm going to make the numbers nicer. So here's what you want to do. I'm going to make the numbers nicer for this problem to pretend we have better data. What would the answer be if this is a test where the test has a mean of 80 and a standard deviation of 10? Well, the answer must be between what and what? Logically, between 90 and 100. But what is the answer to what is the observation? Just think about mathematically what you're doing is the observation y is equal to the mean plus the z-score times the standard deviation. If you start plugging in your numbers here that you have, you're trying to use the z-score right here. Yeah, exactly. About 93. Perfect answer right there, Jackson. Are you starting to see it? Because you could just times that by 10 and add it to the mean, because that's how many standard deviations you're going up. And the less you need to memorize the formula, and the more you're like, oh, I'm just going this many standard deviations above the mean, you start to see it and be like, that's what a z-score tells me. It says, go this many standard deviations above or below the mean. So how about this? If I were to put in the 20% right here and it says the bottom 20%, this is where people get stuck. The bottom 20% wouldn't have a positive z-score. It would have a what z-score? The bottom 20% wouldn't have a positive z-score. It would have a what z-score? The bottom 20%, it would have a negative z-score. So if we times this by the standard deviation, and so we're just doing how many standard deviations this is, and subtract it from the mean, we get this answer here, and we drop in this answer, and lo and behold, we've got another question correct. Now, the last one right here, we could do the outer 30% on either side, or we can just solve it a little bit quicker. This question is not nearly as, I don't know, this part is more meh. And there's the answers. Well, there's the z-scores. Oh, it was pretty close, I think. It's going to be a little further out. It's going to be more like this and like this. I might get it. Nope. But it's a little further out because I said half a z-score if you rewind the tape way back when. And then we go here and we do these. And there is the, it's even further. It is down there. So I was pretty close with my guesses. Decent enough. And it is symmetric about these numbers. So we had to go that much out further. And that should do it. That's 100. So once again, with this question, you can literally just go to the applet and enter in all the numbers. And you can just do the, like, you know, below the bottom 20%. And it will just give you the answer right there. You can see it, and you can round to one decimal. You can do the top 10%, and it'll just give you the answer right there. And there it is. You can do the middle 40. And we're just practicing to understand this better. And you can do the middle 40 by doing the outer 60. And you still see the same thing. So there's the numbers, the lower and the upper bound for the 40% in the middle. Does it make more sense? That's how kind of we can do it on the test. They are tricky, so practice makes perfect. Same thing going on with this one right here. Same thing going on. Similar question. How many of these can you get? Go ahead, 1,000 points again if you can get them before I can. Ooh, we got some nice numbers here. Oh, we got such nice numbers. I can do a lot of these. I think I'm going to make, not kidding, I'm going to make at least a 75 on this. So start doing this problem as I take the timestamp. We got just enough time here. We're going to finish the full quiz. I think I can make, without the applet, I'm not even kidding, I think I can make a 75 on this. The highest 10% is a z-score of 1.2816. That means this is going to be 100, oh my gosh, slowing down, 112.8 right there, I think. The bottom, the lowest 35%, that is a ridiculous thing. No one finds that. No one finds that. So I'm just going to take a random guess. Oh, answer, oh, I did get it, Jackson. Jackson's solving it along with us. This one I'm going to guess before Jackson gets to the next one. Jackson, 1,000 points, you're on track with me. I'm doing it in my head, though, Jackson. The lowest 35, and I will show this afterwards, is, I don't know. I don't know. It's 96.7, sure. The cutoff for the middle values of the middle 90, that is a z-score of 1.645. So we have to go 16.5 down. So that'd be 83.5. And then we have to go 16.5 up. So that's 116.5. We should get at least a 75. Yep. The middle one, I just don't know. There it is. Jackson got it. And I was just a little bit off. We now have 100. And Jackson earned everyone 1,000 points. Thank you, Jackson. So once again, I've done the curve a lot, so I can usually guess these things, and I know where 68, 95, 99.7 is. So I was trying to draw this out in my head. To solve this, please go to the applet on the screen currently. Great job, Jackson, right there. Put in the mean of 100 and the standard deviation of 10. Make sure you have it written out. And then we are going to use the percent right there. Find x using a percent, and we're going to go to the highest 10%. We need to make sure it shows the highest 10%, and that's 1112.8. And once again, if you're wondering why I knew these, it's because I've memorized the what's for these. The reason I knew this answer and I knew the last one is because Brian gave me one letter for more points. I had memorized this what. I know where the top 10% is every time. I memorized the z-score. And then for the last one, it said the middle 90. I know that's 1.6449. So the middle 90 right here, if you go to the middle 90, is 1.6449. So I was automatically using the z-scores. You're not meant to memorize the z-scores. I've just done this a lot, and I know what the z-scores are. So I was doing the work in my head of what is the mean plus or minus this many z-scores. But with this right here, you can see the middle 90, And if you put in the context of the problem, you can get the direct answers of 83.5. It gave it to me, and 116.5. And then you go to the hard one, the bottom 35%, which is a very hard one to guess because we usually don't talk about those, and round down to one decimal, and you get 96.1 or 96.2, either which way. But all in all, this is a great question, and try drawing it out, see how many you can solve, and if you can get decent guesses. I promise it's a really good way to know the curve, is to try to draw it out. Here we are with our last few questions. We're going to get the full thing done. I got to keep going because we got just enough time. The full entire quiz, every question for you to review. We will have it. Okay, so this is at the 104.23, and we got companies who design. Okay, there's companies who design stuff for kindergartners. We got a mean, we got a standard deviation. So what are we going to do? We're going to drop it into the applet. We'll do this one a little quickly because we're short on time. But we're going to drop these numbers into the applet, the mean and the standard deviation. Although they didn't put a space right there, we'll still do it. And it wants to know about what percent of kindergartners will be higher than 36 inches tall. Well, 36 inches, less than. It's going to be about 7%. Let's find out. So we find the percent using X, very important right there. And we go down here and we go below 36 inches, make sure it's below, and we got to do our decimal rounding. And it's 4.6%. I was off, but that was a very quick guess without a sketch. And next we find out the middle 90%. Once again, I know the z-score for this, so I could find this, but let's just show it. The middle 95% is going to be, we go to find X using the percent, and we go to middle 95 right here. And the answer is going to be those two answers right below here. The middle 95% of kindergartners' heights are contained between 35.5 to 42.9. The biggest kindergartners are going to be over here on the right side of the curve, and that is the what percentile. For 1,000 points again, the top 15% is also known as the what percentile on the curve. So you have to think what percent is below here. The top 15% for 1,000 points is known as the what percentile. That should be all the answers correct. Oh, what did I do? I did this one wrong. What is going on? Because there's two answers wrong. So that means I did that one wrong. The 85th. Great job, Keely, right there. What did I do? Between 90 and... Did I type 80 or something? What did I do? Someone check the tape on that. Am I getting punked? Is Ashton Kutcher here? What's going on? I don't know what's going on. I don't know. Very similar problem to what we've been doing right here, so I'll probably do this one a little quickly too. Once again, these questions are very repetitive, and that's why I love them, because if you can do some of these questions, you can probably do all of these questions. The more of these you get down, this chapter, I think, is one of the easiest, most repetitive chapters there is. I love it. It's a great chapter. 106, 43, and let's go over here. Use the normal. Steers. Okay. All we're going to do is we're going to go to the applet. Applet is in the chat right now. Just click on the applet. And we go right here. We enter in the mean on the curve. Who feels like this chapter is way easier now that you've seen this? The percentile means area below. So the 59th percentile is the area below this point right here. It has to be above the mean because the 59th percentile would be above the 50th percentile mark. Nearest whole number found. And we'll even have the applet do that for us. So the applet's now going to round to the nearest whole number. 93rd percentile is actually where the top 7% is. So you can remember that right there. The top 7% is the 93rd percentile because 93% of data is below this. And the IQR is the middle 50% because the IQR stands for the middle 50%, the inner quartiles. And there's the IQR boundaries, or the length of the IQR. So it wants us to subtract these two numbers, which looks to be about 101, and that should do it. That should be the IQR. Once again, IQR is Q3, which is 1177.59 minus Q1, and that has got it right there. There is the IQR's range from these two numbers. You could also find out Q3, which is going to be below 75%, and then you could find out Q1, which is below 25%. And this lands at 102, which this does have some leeway, and you do still get it correct. 103 is probably going to be wrong, though. Nope, it is wrong. Well, that's 104. Yep. 101, 102. Can you do 100? Ooh, a little leeway on the question. We like that. Okay, the last one right here, very similar. Does anyone feel like these are way easier now? Did anyone like complete questions I wasn't even doing while we were doing this? I feel like I've lost. It's all right. I feel like if you were like, I got this now. I'm feeling good. And people said, like, if we had questions, we'd ask. Got normal model IQs right here. This wants the 18th percentile. We're going to enter in the mean and the standard deviation here. Then we're going to go to the 18th percentile, which is 18% of the data below. And that is the IQ right there, 1 decimal, 88 point what? 2? 1. Oh, I would have got it. 88.1. Next, we go to the 95th percentile. Ooh, can I do that one? 95th percentile, that's a tough one. Yeah, Mackenzie, this is my favorite chapter maybe. It's such a foundational chapter for statistics. But fall asleep. Yeah, 95th percentile. Oh, I know where that's at. That's going to be at a z-score of 1.645. So I need to take like 2/3 of this. So it's going to be about 120.3. And then the IQR is 1 1/3 standard deviations. So I need to take 1/3 of that, which is like 4.3. So it'd be 17.2, round down. We missed one of them. So here's how to get the answers on the screen. Is to find the 95th percentile. We go here and put in 95. And it looks like this is the one I got wrong because I was guesstimating. And there's the answer. And then last but not least, to get the IQR, you need to go here and do the middle 50% and subtract the two numbers from Q1 to Q3. Q3 right there. I almost said a wrong Q. I was like, Q what? And you just take the numbers. Q3 is this. And Q1 is this. And there's the IQR. And somehow magically it gave it to me. I must have been on the very boundary. I should not have rounded down, but I was on the very boundary of the possible answers via my guess. So it is more 17.5 when you mathematically subtract Q3 minus Q1. Well, that's got it. We've completed the full entire homework and quiz in just a little over an hour. Every question done with a help video walking through the steps. A little quick, but join in if you want questions answered. I don't know what that means. Well, Jackson, good work. I'm going to head off. I'm going to be teaching class here in just a few minutes. Until then, bye for now, everyone. Bye.